Okay, the ring topology. The ring topology, in a ring topology, each device has a dedicated point-to-point connection. As you can see here, each device has a dedicated point-to-point connection that is known as the repeater sections, and connection with only the two devices and either side of it. A signal passed along the ring in one direction, that is the one direction directed design, and from a device to device until it reaches its destination. Each device in the ring incorporates a repeater. When a device receives a signal intended for another device, its repeater regenerates uh, the bits and passes them along. The bits and passes them along. The repeater regenerates. So that is a single line ring topology. So what are the advantages? The advantages of ring topology is all data flow is in one direction, reducing the chance of packet collisions. So there is a less chance of packet collision. A network server is not needed to control network connectivity between each workstation because there is a single line flow diagram and a line flow cable run through the total network. Data can transfer between workstations at high speeds. High speed communication are there. Additional workstations can be added without impacting performance of the network. Without impacting the performance of the network. What are the disadvantages? All data being transferred over the network must pass through each workstation on the network, which can make it slower than a star topology. Star topology has a hub, central hub. So all the data being transferred over the network must pass through each workstation on the network. So each and other workstations will be connected through to the repeater. So the entire network will be impacted if one workstation shuts down. It's a very serious thing. The hardware needed to connect each workstation to the network is more expensive than Ethernet cards and hubs and switches. So it's a very expensive topology too. Okay, let's go through to the hybrid topology. So hybrid topology is one kind of topology that has been incorporated with different topologies. Just they incorporate different topologies with each other. As you can see here, in this hybrid topology, there is a central hub. As you can see, point to multi-point connections, that is the star connection, and there is a backbone connection, as you can see here, and each of the backbone has a tab. So similarly, there is a cable end and tab. You can say this connection is a bus connection because there is a central cable, okay, the backbone cable, and the central hub connects with it. That is the star topology. The star and bus topology. The star topology in the beginning and end, that is the bus topology. There are some tabs right there to connect there to make the interconnections with each other. So that is the hybrid topology. So for this hybrid topology, now the internet came into forward. The internet has revolutionized many aspects of our daily lives. It has affected the way we do business as well as the way we spend our leisure time. The internet is a communication system that has brought a wealth of information fingertips and organized it for our use. As you can see here, there's a conceptual view of internet. So you came to know about the backbone of the networks in the previous lectures. That means the bus topology, and there are some point to multi-point connections in the service provider to another users and nodes, as you can see. So the customer network that is being used to the star topology, because there are different provider networks and different servers. There are the controller stations, and each backbones are connected to each other. That is the hybrid topology that you can see. That is the server, that is the star topology, and here we can see the bus topology in the internet. So now some uh, hierarchical organization of the internet. So actually, if you want to explain the structure of a national ISP means the internet service provider. So the internet service providers are connected to the regional ISPs. So after that, the regional ISPs will be connected to the national ISPs. Okay, so there are some ISPs, internet service providers, right there. You can go to your locality and take an internet connection from a server. They are practically known as internet service providers because they have been licensed from the Bangladesh Telecommunication Regulatory Commission or any kind of regulatory board, those who give the license to use the uh, broadband connections or the, what can you say, frequency or wavelengths uh, to communicate or use the data flow. So these ISPs are the regional ISPs under the regional ISPs, and regional ISPs are under the national ISPs. So interconnection of national ISPs, as you can see, the total national ISP will be controlled by the NAP, that is the host or central point, okay, of the ISP. So that is the part of the IGW thing, that is the internet gateway. So that is the internet gateway, the IGW. Each and every IGW will be connected to the ISP, internet service providers, regional ISPs, and then the ISP of your locality, what you are now served. Okay, now the protocol and the standard, two different type of things. What is the protocol and what is the standards? First, we define protocol. Protocol means a set of rules. Okay, so a protocol is a set of rules that governs data communication. It defines what is communicated, how it is communicated, and when it is communicated. Key elements of protocol: syntax, structure of format of data meaning the order in which they are presented. Semantics refer to the meaning of each section of bits, how a pattern is interpreted, and what action to be taken. And the timing refers to when data should be sent or how fast can they be sent. These type of things are particularly uh, used by the protocol, and they are the parameters of the protocol. So what are the standards? As you can see, 3G standard, 4G standard, 5G standard. Standards are essential in creating and maintaining an open or competitive market for equipment manufacturers, required to guarantee national or international interoperability of data and telecommunications technology and processes. Category of data communication standards, that means de facto standards that have not been approved by an organization or body. De jure, those that have been legislated by an official recognized body, that means OSI model. And we will know the TCP IP and OSI model, that means the standards, on the later section of our lectures. Thank you very much for being with